So in this video we're going to add radicals. Just a vocabulary review. The number in front of this is the radical sign, and the number in front is the coefficient. The number underneath the radical sign is called the radicand. So when we're adding or subtracting radicals, our first step is going to be to simplify the radicals. To simplify the radicals, we want to find the largest perfect square that divides evenly into it. So just remember, we have our list of perfect squares. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. So we can generate this list. In this example, the numbers are 18 or less, so we don't really need more numbers, but you could keep going. So for 18, I look at this list and I know that 9 divides into 18, so I'm going to separate this into 9 times 2. Now 9 is a perfect square, so I'm going to take the square root. It can come out of the radical sign. Once you take the square root, there is no more radical. But here the 2 is not a perfect square, so that stays stuck underneath the radical. We're going to do the same thing for the 8. So if you look on the list, 4 divides into 8. So I can rewrite the 8 as 4 times 2. Now we know that the square root of 4 is 2. So that 4 is going to turn into a 2. The multiplication is between the terms. So in our next step, we can say 3 times 2 is 6. And now that they have the like radicand, right, they both share the 2, I can actually combine them together. Similar to fractions, we would keep the radicand, so we're going to keep the radical 2, and we would add the coefficient. So here 3 plus 6 gives us 9, so that would be our final simplified answer. Now if we got to this step here, and we couldn't simplify any further, and they still didn't match, then that would be our final answer, but since these match, that would be able to be combined to give us 9 radical 2. So just to recap, first you simplify the radicals, and then you add them only if they have like radicands, which we did here. Thank you.